Look at the first one. The first one says the area of a circle is given pi r squared. All right, so we're just looking for pi r squared. All we need is the radius. So in example 1, it says, what is the area? What is the area of the circles? Round answers to the 10th place. So you just need to make sure you're always using the radius. So if my diameter is 20, what would my radius be? 10. All right, so here we have area equals pi 10 squared. All right, and your little pi button is right next to the sign button. All right, the pi button is right next to the sign button. Okay, so just make sure you use the pi button. All right, so everyone enter pi 10 squared. What do we get when we enter pi 10 squared? Going to the 10th place, 314.2. All right. All right, next one has the radius of 2. Go ahead and try that one for me. Just given the radius already. All right, what did we get for this one? 12.6. All right, and then we get into this one. This one's talking about an outdoor accessory. It says for a outdoor umbrella. It's a cover for the umbrella. It says if the cover is 8 inches longer than the umbrella on each side, find the area of the cover in square inches. So it wants to know the area that we have here. Oh no, it wants the area of the whole thing, right? Because that's just a circle that's going inside. It wants to know what would it cover, because it would cover the outside and then in addition with those 8 extra inches on the side. So then what would your diameter be? Well, you have 72 in addition to 8 on each side. So what would your diameter be? Diameter would be 44? Would be 88, right? Given your radius is now 44. All right, let's go ahead and get our area here. That now we know that the radius is 44. What'd you get? 6,082.1. All right, 6,082.1. And then your unit squared. All right. Over on the right side, we're just going to go backward. All right, so this one's given the... All right, so on the next page, sorry about that. It says find the radius of a circle with an area 95. So this one's just working backward, given that the area is equal to pi r squared. Where am I plugging in that 95? Just in for A. All right, now I want the r to be alone. I want to isolate that r. So then what do I need to get rid of first? The square first? The pi first, all right? So divide 95 by pi. Divide 95 by pi. What would our radius squared be equal to? 30.2. All right, and then what should I do to get rid of the square now? Square root it. And y'all can round this to the tenths. Well, what did we get to the 10th place? 7.5? 5.5? All right. So just remember when you're working backward, got to get rid of the pi first and then take the square root, okay? So here's the area of the sector formula. Very similar to the arc length because it has that proportion. The central angle and that 360, this is staying the same. This is not changing. All right, that's going to be your constant number. That's going to always be there. And then we have the area of the sector. So this would be like the whole slice of pizza out of the full pizza. It's all it's looking at, all right? So that pi r squared, unlike arc length, pi r squared will always be the formula down here at the bottom, okay? So here it says a circular pizza has a diameter of 12 inches and it's cut into 8 congruent slices. What is the area of one slice to the nearest 10? So if I wanted to use this proportion, What do I know is already on my formula? What should always be there? 360. That's 360 degrees. It wants to know the area of one slice. Now I have to figure out the radius. Do I know my radius? Can I figure it out? Yeah. What's 12 divided by 2? Good. Your radius is 6. So I'm going to put pi 6 squared. All right. Now I have to figure out my degrees. How am I going to figure out my degrees? Because they didn't give me a degrees this time. 360 divided by 8? Because there's 8 congruent slices, right? So let me just show y'all. So there's 4, 6, 8. If they're all equal, I need to know that central angle. So then 360 divided by 8 gives us 45. So 45 degrees would be our degrees. All right, so just like I did before, you're going to multiply this first. Now, if I had to type this in myself, I would put the 45 first, just so I can enter that 6 squared at the end and not worry too much about it. So I would do 45 pi 6 squared. All right, leave it idle there. All right, and then at the very end, after you hit enter, so just hit enter. All right, once you have it entered, after that, just press divide by 360. So now just hit divide by 360, and it divides your answer by 360. We get 14.1. Oh, it goes to the hundreds. So 14.14. All right, that would be the length, or the area, sorry, of one pizza. All right, so you have the same idea. This time you have a pie. The diameter is 9 inches, and it's cut into 10 congruent slices. Find me the area of one slice to the nearest hundredth. So given that the diameter is 9, what's our radius? 4.5. So I would have had x over pi 4.5 squared equals, for 10 congruent slices, what would the degrees be? All right. Then we cross multiply. Again, if I entered it, I would put just the 36 in front to kind of just keep my numbers separate with that pi. What did y'all get for the x value after y'all divided by 360? 6.36? All right. Now, these could have been done a lot easier, right? Because it's just a pizza and it's being cut into 8 slices, a pie being cut into 10 slices. Now, I did have y'all do it with this formula just because of that next part that we're going to get to. So if it's just cut into 10 slices, you could just take that area. Can somebody do pi 4.5 squared for me? Let me know what you get. Somewhere around 63.6. Can you go ahead and divide that by 10 for me, since there's 10 slices? 6.36, which happened to be the exact same thing. Again, we didn't have to use this one just because it was cut into 10 congruent slices. We could have just divided that by 10. Now, when should I recommend you do use it? If you go over to the back side, I wouldn't recommend doing it on this one because these are not equal slices. I don't even know how many slices I'm going to cut into that 60. Could we figure it out? We could. All right. So if I wanted to find the area of just the shaded one, just the shaded slice, I would do that missing slice out of the total area. What would I write for the area for pi r squared? I would put pi 10 squared because that's your radius. Good. 10 squared. What's your degree? And then divide by 360. All right. So let me have you guys figure out that measurement real quick. And again, we could do this the other way, right? You just have to figure out how many slices we would get if it was 60 degrees, if you wanted to go the other route. What'd you get, Chris? 52.4? Yes. All right. Now, if you look at the one on the right, this one wants the shaded pieces of the following. So this one will not divide evenly, that 158 at least. So this one, again, this proportion is what I would recommend on this one. No, maybe not on those other ones on example 3 and practice 3. But on this shaded region, if you notice I gave you the degrees of the non-shaded region. And there's 2 of those, right? How do I know there's 2 of these? Because these are what type of angles? Vertical angles. How would I find the degrees of the other 2 together? Take those and subtract it from 360. Can y'all do that for me? Can y'all take those and subtract it from 360? 360 and the difference of 158 degrees. 44? All right, 44 degrees it is. Always out of 360. The radius is 4, so pi 4 squared, and then your x. All right, let me know what you get for your x value on that one. What is it? 6.1. All right, so then if I asked you for the non-shaded region for this one, how would I figure out the degrees for that one? What would be the first thing you'd have to do? You could do 360 minus 60, right? Because that'll give you the 300 degrees. Everything else would remain the same. The other thing you could do is given that you already know the whole area by doing pi 10 squared, right? And then knowing that this is the area of the shaded, you could subtract those and then get the area of the unshaded. You could also do it that way if you wanted to. Whatever you want to do. All right, let's look at this one here. All right, this was asking for the area of the circle. So this is where it starts, the x starts to move around on the proportion. Where's that area of the circle located at the top or the bottom on the fractions? Where's the area of the circle located at on this proportion? At the bottom, because remember, that's a total. That's a total measurement I'm looking for. I gave you the area of the shaded. This is the area of the shaded. That's part. I also gave you the degrees, which is part of the total. All right, and then from here we can cross multiply and figure out the total area of the circle. All right, so what would be our total area here? $106.65. All right. All right, what's this one? This one's asking for what? What do you think the question's asking for? The central angle. Where's the central angle located at? Right above the 360. All right, do we know the area of the sector? What's the area of the sector? 10 pi. All right, so we're going to put 10 pi there. What am I going to do for the area of the circle? I'm going to put pi 10 squared. All right, so don't do anything yet. Anytime you have pi's, keep the pi's there. 10 squared, what would be 10 times 10? 100 pi. Y'all could simplify this a little more if you wanted to. You could leave it like this if you wanted to. I mean, if you want to leave it like that, cross multiply and divide, you can. But the pi's cancel out. The 1 over 10 reduces to what? 1/10. So now you could really look at this as 1/10 is equal to x over 360. And that just makes your numbers a little smaller, easier to work with. So what do we get for the angle? Round that one to a whole number. What would we get for the angle? 36 degrees? 36 degrees. All right, when you're ready, we'll go to the last page. All right, the last page. Go ahead and shade in these shaded regions because, again, the shading doesn't always show on your notes. It says find the area of the shaded region. How many shaded regions do I have? 3. Can I figure out the degrees of one? Yeah. How are we going to find the degrees? 360 divided by 8 is what? 45 times 3 gives us 135 degrees. All right, so when I make my proportion, that 135 degrees is the one that's going to go above that 360. All right, I'm going to get my total area of all 3 all at once. What did I give you, the radius or the diameter on this one? The radius, so pi 13 squared. All right, go ahead and multiply that for me. And then we'll get into the composites. Did y'all get 19.9? Did y'all get 32.1? What'd y'all get? $22.4? 199.1. 199.1. All right. Yeah, I'm just start throwing random numbers at y'all and see if it's the answer. All right, it says find the area of the shaded region. Break it up into the least amount of shapes. Least amount of shapes. What would y'all recommend I break that first one into? Well, one of them's not even a shape we've really studied, but it's part of a shape we've studied. What would it be? How much of the circle? Half of your circle? But if I cut it here, is it half of a circle? A fourth of a circle, right? That's a fourth of a circle. What's the bottom shape? A trapezoid. All right, so how much of the circle we said? All right, so I'm going to take a fourth of the circle, and I'm going to add it to a trapezoid, right? I'm just writing down what I'm looking at. So you're going to take your circle formula, the pi r squared, and you're going to divide whatever that is by 4, and then add it to your trapezoid formula. Do you have the trapezoid formula memorized yet? What is it? Good. All right. What's the radius of the circle? 4. Okay, so we're going to do pi 4 squared divided by 4. What's our first base on the trapezoid? 4. What's that second base? Good, it's right here. It's 9. What's the height of that trapezoid? 2. Good, that's the height. All of it divided by 2. All right, and just simplify as much as possible. What's 4 squared? What's 4 times 4? 16 pi divided by 4 gives us 4 pi. That's your circle. 9 plus 4 is 13. What's 13 times 2? 26 divided by 2 is 13. All right. Now all you have to do is figure out this number and add it to 13. What do we get for the area? $25.6. All right. Now the circles are going to be different. You're going to have some of these on your homework. I think I even might have put some on the classwork that's to come. How do you think I'm going to find the donut?
So then you go 2 4s on each side vertically, so then it's 8, so it's 28 all the way.
All right, so he added everything together and already knows that diameter is 28 here.
Yeah.
Okay. So how do I find the area of the donut? Can I find the area of the big circle? Now, if I find the area of the big circle, this is what you're going to give me. Then you have to subtract the area of the small circle so that all you have left is the donut. Okay, so I'm going to leave that picture there because I'm going to come back to it. Let's go ahead and do that. What's the area of, I'm going to say the area of the big one minus the area of the small one, because they're both pi r squares. What's the radius of the big one? Now that he found the diameter for us. 14 squared. What about the radius of the small one? 10 squared. Don't put the pi in yet. Can someone give me, do y'all have it memorized? 14 squared? What was it? 196. And 10 squared is 100 and then pi. So when you're dealing with circles with the circle, and again, you're going to see this, keep it in terms of pi, because then it makes it a little easier for us to subtract and then calculate a more accurate area. What would be 196 minus 100? So this is 96 pi. So now all you have to do put that in the calculator, and it shoots out the accurate area for this. So what would it approximate to? What is it? 301.6. All right, so I left that picture there because I said I was going to come back to it. What if I came back and said, oh, I'm going to find this area too. So now I want the area of all of this purple section. How would I find that area? Do everything I just did. All right, so I'm listening to him. But he said add an extra what? Okay. So he said do the same area, so big. I'm going to say minus medium. Do I want to minus the small one? No, because I want the area of the shaded one. So you're going to have to add the area of the small one. So let's just say, and this is just an example, right? I'm going to just kind of make a circle here and just put example. Let's say I had 4 pi minus, sorry, not 4 pi. Pi 4 squared minus pi 2 squared plus pi 1 squared. What's 4 squared? 16 pi minus 4 pi plus 1 pi. Good. What's 16 minus 4? 12. What's 12 plus 1? So 13 pi, whatever it may be, would be your final answer. All right, so just kind of keep that in mind, because again, you'll see it. All right.